In this video, I'll be showing you guys how to plot points on the polar plane. How can you plot points with negative radius, and how to plot points with angles greater than 2 pi. Alright. So, first example I would like to show you is 3 pi over 4. Very simple to plot. Now, if you don't know how to turn this guy into rectangular coordinates, or what the concept of a polar coordinate is, then go ahead and watch the video down below in the description, Introduction to Polar Coordinates, or Introduction to the Polar Plane. That's very important to know for this video. It'll help you out a lot. But let's say our radius of our polar coordinate is 3, and our angle is pi over 4. So this is the order in which it's written for polar coordinates. The first value is the radius, and the second value is the radians, or the angle. And I'll show you what I mean by angle soon. But what does the radius stand for? Well, the radius stands for the distance from the origin. So the origin is the center where this green dot is. And each of these little web things, these circles that you see expanding out further and further and further, stand for a radius of 1 in the polar plane. So if our radius is 3, we want to look for this third circle from the origin. So this is the first circle, this is the second circle, and this is the third circle right out here. Okay, the circle kind of overlap with the fourth one, but you know what I mean. So this right here is the third circle, this guy right over here. Now, what does the radian stand for? Well, the radian stands for the angle formed from the positive horizontal axis. So in this case, I plotted out all the possible radians here. All right, this is very helpful. Most polar planes will look like this, but sometimes you might not get a radian that's on along one of these very specific radians, or at least along a rational radian. You know what? I don't know if rational would be the right word, because pi is irrational. But along one of these values, you might not get exactly that. You might get a point that's like maybe at this angle right here. But in this case, you have pi over 4 radians, and you are at a radius of 3, or distance of 3 from the center of the origin. So we want 1, 2, 3. This is the third ring. And we want to plot this point along the third ring along pi over 4 radians. Now, if I were to draw a line from the origin to your point and form the angle with the positive horizontal axis, then you would get pi over 4 radians, which is exactly what this pi over 4 radians means. It's just the angle from the origin if you were to draw a line from the point to the origin. Oh, wait, what am I saying? The angle between the point and the origin and the positive horizontal axis. There you go. So pi over 4, 3 pi over 4 is this point right here. Let's go ahead and save that. Let's go ahead and look at another point. Let's use yellow again. Let's go ahead and look at, let's say, 5, 2 pi over 3. Go ahead and try this out yourself. So 5 pi over 2 pi over 3. 5 is the first ring, second ring, third ring, fourth ring, fifth ring. So the fifth ring is the outermost ring in this case, and we want to be at the radians 2 pi over 3. Conveniently, the point is exactly along the 2 pi over 3 line, and if we were to form a line from the point to the origin and measure the angle between this line and the positive horizontal axis, or I guess the positive x-axis, then the angle that this guy would be is 2 pi over 3 radians. If you want this in degrees, this is 120 degrees. So this angle right here is 120 degrees. But this is the second point in this case. All right, let's go ahead and talk about other cases. What about the case when the magnitude is negative? Negative 1, let's say negative 1 pi over 3. What is this? All right, well, you can kind of just remove the negative in your head for now and just look at 1 pi over 3. Well, what is 1 pi over 3? Well, 1 is along the first ring, and pi over 3 is along this angle right here, or this line right here. So the point would be here, correct? If you have a negative, you would simply be on the exact opposite side. So in this case, the opposite line or the opposite side is this point right here. I know the lines can be a little confusing in the center, but this one right here is negative 1 pi over 3. Well, what do we do? Well, all we had to do if we have a negative is either we flip the side, or what we can actually do is turn the radius positive and actually just add plus pi onto the angle. All right, plus pi is 180 degrees, and if you add 180 degrees onto something, you simply go to the other side, correct? Well, in this case, we have 4 pi over 3, right? If we add pi to pi over 3, we get 4 pi over 3. Isn't this exactly where this point is at? Along the 4 pi over 3 angle, and still has a magnitude of 1, since it's along the first ring. So these 2 points are fundamentally equivalent. These 2 right here are equivalent. So in terms of the location on the polar plane that you're describing, these 2 points are exactly equivalent. They plot the same point. All right. So if you're confused about the negative radians, all you can do, negative radius, all you really have to do is just plus pi onto the angle and then remove the negative. Okay, how about in the case where you have, let's use pink. How about in the case where you have, let's say, 3 negative 7 pi over 4. Okay, what is this? Oh, might have to clear some space for this. What is this? Well, this right here has a negative. The angle that you see here is not any of the angles that you see along your polar plane, correct? Well, the thing about this is that, again, when you have an angle, this is not again, I guess it's not really again, but I'm going to show you something that's fundamentally equivalent again. When you have an angle, let's say 20 degrees, if you add 360 degrees onto it, you get 380 degrees, correct? Well, 380 degrees and 20 degrees really show you the same angle. All right. So if you add 360 degrees or 2 pi radians onto this, you really get the same angle. So let's go ahead and add 2 pi radians onto this. So if I were to turn this guy, the radius is the same, 3, and we had negative 7 pi over 4. If we added 2 pi, we would get pi over 4. If we add 2 pi onto negative 7 pi over 4, we would get pi over 4. So what point would this be? Well, 3 pi over 4. We already know to do this. Technically, this is actually just, I guess it overlaps at this point right here, but it's the exact same point as 3 pi over 4 and negative 7 pi over 4. These are fundamentally equivalent. They plot the same exact point on your polar plane. All right. So now that you guys know that, you really could end the video if you get the rest. But let's do a couple examples. Let's do negative 4, negative. Let's see, negative. Ooh, actually, how about 7 pi over 3. All right. So 7 pi over 3. What is this? Well, 7 pi over 3 is actually above 2 pi, right? 7 pi over 3 is greater than 2 pi. 2 pi is equal to 6 pi over 3. 7 pi over 3 is greater than 6 pi over 3. Therefore, this guy is greater than 2 pi. Well, what is this, right? What is 7 pi over 3? Well, just like how you can add 2 pi to get the same angle, you can also subtract 2 pi to get the same angle. So look what happens. If we subtract 2 pi from this, then we should get pi over 3. Now remember, if you have a negative radius, what you can also do is add pi and then just remove the negative. So let's go ahead and add pi here and just remove the negative. So the new polar point we get is 4, comma, 4 pi over 3. Now this is very easy to plot because we have 4 pi over 3 along your polar plane already, and you also have 4, right? It's the fourth ring. So if I were to plot this, I would get 4 pi over 3, which is right here. Now, what if your angle is significantly greater than let's choose 1,000 pi over 3. What if your number is significantly greater than 2 pi? Right? You can't. It's going to be very tedious to keep subtracting 2 pi, 2 pi, 2 pi, 2 pi. What can you do? Well, you have to understand. If you keep subtracting 2 pi, you're eventually going to subtract some multiple of 2 pi, right? So if you keep subtracting 2 pi, 2 pi, 2 pi, you technically at minus 6 pi. And if you keep subtracting 2 pi, 2 pi, 2 pi, 2 pi again onto the minus 6 pi, no matter what you do, you're going to get an even number, right? Some multiple of 2 pi, correct? So let's go ahead and pick a number that is very close to 1,000 and a multiple of 3. What's a number that satisfies these conditions? 999 over 3, right? Well, 999 over 3 is 333 pi. And here's the thing about this. We can actually make this, let's say, an even number. Pick an even number. Usually I go down if the number is very positive. If this is very positive. It's a large magnitude positive number. I would just bring this number down if it's odd. If this number was already even, great. Okay. So we have 332 pi. Here's the thing about this. 332 pi is the same as just constantly subtracting 2 pi, 2 pi, 2 pi, 2 pi over and over and over again. It's the same as subtracting 2 pi over and over again 166 times, I think. So if you subtract 2 pi over and over and over again 166 times, right? Yeah, 166 times, then you're going to get 332 pi, right? So you can actually subtract 3332 pi from this, and you're basically just doing the same thing as just constantly subtracting 2 pi. So we had 1,000 pi over 3 minus 332 pi. Well, we can make it so that the denominators are the same, right? So we have 1,000 over 3 minus 996 pi over 3, which is equal to 4 pi over 3, right? And remember, this 9996 pi over 3 is the same as just subtracting negative 2 pi 166 times. Sorry, subtracting 2 pi 166 times, not subtracting negative 2 pi. So the new angle that we actually got after all of this was 4 pi over 3. And 4 pi over 3 is fundamentally the same thing, if you're graphing on the polar plane, as 1,000 pi over 3. So if I were to plot this, I would plot 1, and along the first ring is a radius of 1, and look at 4 pi over 3, which is, well, I guess the same point as this blue point, so another overlapped point. I don't know why I keep choosing the same ones, but this and this are the same thing. All I did was subtract 2 pi over and over and over again, but did a couple math tricks to get 9996 pi over 3 as a number that was a factor of 2 pi. So that's really it for the video. If you have any questions, put it down in the comment section. And if you found this video helpful, you know what? Leave.